Now we will discuss friction. When two objects are in contact with one another, then electromagnetic force acts between the charges in the contact surface. This force is called contact force. This contact force can be resolved into two components, a vertical or normal to the surface and another is parallel to the surface. The component normal to the surface is called normal reaction force, and the component parallel to the surface is the friction force. So this contact force in general has two components, the normal reaction and the friction. Let us take a simple example. Suppose on a rough horizontal floor a 50 kg box is placed, and we are pushing it with a horizontal force of say 50 Newton, and the box is not moving. That means the force of friction comes into play, and this force of friction is called static force of friction, as the box is not actually slipping over the floor but has a tendency to do so. Obviously, the static force of friction at this instant is equal to 50 Newton, the applied force. If we go on increasing the applied force, the force of static friction also increases till a limiting value of the applied force when the box is on the verge of slipping. Thus, the static force of friction is a self-adjustable force up to a limiting value. We call it Fs max. So Fs, the force of static friction in general, is less than equal to Fs max, the maximum value of static force of friction. This Fs max in turn is directly proportional to the normal reaction the surface exerts on the block. And the proportionality constant is what we called the coefficient of static friction, the mu s. The magnitude of this mu s depends on the nature of the surface, that is its roughness, and also it depends on the material of which the surfaces are made of. When the applied force on the box exceeds this maximum value of static force of friction, the box starts slipping over the floor. And now the force of friction that comes into play between the box and the surface is what we call the kinetic force of friction. This kinetic force of friction is also directly proportional to the normal reaction experienced by the box, and we say that kinetic force of friction is equal to some constant mu k into n, where mu k is the coefficient of kinetic friction. In practice, generally mu k is less than mu s, and in general we ignore the difference. If not otherwise mentioned, we consider mu k is equal to mu s is equal to mu. This situation will be more clear if we plot a graph between the applied force and the force of friction that comes into play. Initially, till the limiting value of friction is reached, the applied force is equal to the static force of friction. So the graph is a straight line with slope 45-degree passing through the origin. This is up to the maximum value of static force of friction. And thereafter, if the force is increased, now the box slides and kinetic force of friction comes into play, which is a constant force but slightly less than the maximum value of static force of friction. So there is a drop, and then the graph runs parallel to the force axis. This gives us a better idea about how the applied force and the force of friction are interrelated. This inequality that we have come across, that Fs is less than equal to Fs max, which in turn can be written as Fs is less than equal to mus into n, is a very important inequality in the study of friction that helps us in understanding the different aspect of the force of friction and the motion arising out of it.